Hi all, welcome to Konpira Maru Wine Chat 5.0. And look at this, a whole new world of technology for this week. Last week I was talking about the pet nats we made in vintage 2020, just before lockdown part deux, which we find ourselves in now. And post that, had a few conversations with people about the actual science behind pet nats and how they're made. So I thought, you know what? Let's talk about it. Konpira Maru Wine Chats, episode 5. Last week in that episode 4, I opened a bottle of our Chevauché Leclerc 2020. It's delicious. And it bottled up right up the neck. And I said, it's probably because it's pretty warm. This week I've got a cold bottle. It's come straight out of the winery because it's absolutely freezing. Actually snowed here yesterday. And you can see this one, a lot of carbonation, but it's not ferociously bubbling up the neck. So hopefully as part of this conversation here, we'll see some of the science behind that and why that happens. Just another good excuse to drink our pet nat really cold. So this I call pet nat production, a semi-quasi-scientific discussion. May even be pseudoscience at times. We'll see how we go. Now don't judge me on this. If I don't go into the hardest of core science because I'm just keeping it nice and approachable. If I say something wrong, I'm not wrong. I've got a PhD, so pretty much everything I say is correct. So let's start. You can't talk about pet nats without talking about fermentation. So what actually is fermentation? Where does this carbonation, which we speak, come from? Well, this is fermentation itself. It's the process of converting what we call simple sugars, fructose and glucose, with the equation C6H12O6. So that's 6 carbons, 12 hydrogens, and 6 oxygens, all in a nice, neat ring formation. Gets converted by yeast as part of their metabolism to ethanol, CH3CH2OH, 2 of those puppies, and 2 carbon dioxides. And it's the carbon dioxide in solution created by the ferment that leads to the carbonation and the bubbles that we get. Now, I'll tell you what, there's a question often asked is why do yeast do this? Why do they convert sugar to ethanol and carbon dioxide? I should point out this fermentation takes place, this particular equation, in the absence of oxygen. It's important. So why do they do this? Well, they essentially do it just to acquire themselves a free electron that they can use to drive their cellular processes. So, whenever you're walking out of a room and you leave the light on, you go, you know what? I'm not going to turn this light off. I've got LED globes. I don't need to turn the light off. You know what you're doing? You're wasting electrons. And think about how hard yeast have to work to get these pesky electrons, and you're just leaving the light on. So remember that next time you're leaving a room. So there we got it. Sugar turns to ethanol and carbon dioxide, which leads to our carbonation. So let's see all this within the prism of actual wine. I should point out at the end of this presentation, we're going to move to a spreadsheet. So I apologize for that. Probably won't translate terribly to a video, but we're going to do it. So the basic principles of pet nat production. Let's start with these 2 side-by-side little vessels here. Pet nat production really is just the creation of a pressure vessel. Well, all sparkling wine is the creation of a pressure vessel, which is our bottle. And our aim of the game is to lock up this carbon dioxide being produced by the yeast. So if we look on the left-hand side here, we have, let's pretend this is a bottle, and we have our wine or our grape juice fermenting in this open bottle. It's producing ethanol, we know that, and it's producing carbon dioxide. Carbon dioxide's a gas, and it's a lot less, less dense than the liquid. So some of this gas will dissolve into the wine/juice, but a lot of it will just escape to the atmosphere because the lid's off. And what it's following is essentially a pressure gradient. There's more pressure inside the vessel, lower pressure outside, so it goes from high pressure to low pressure. And wait for it. There it goes. Now let's imagine, instead of having the lid off, we have the lid on. Same process, fermentation process is happening inside this vessel, ethanol and carbon dioxide being produced, but this time, our CO2, it's got nowhere to go. So all the CO2 that's produced is now stuck within this bottle. Now CO2, as I said before, is less dense than the liquid. It fills up. It wants to fill up more space than the liquid for the same amount of the two. So here we have this CO2 building up, building up, building up in this vessel, but nowhere to go. And because it's constantly trying to expand, and the bottle is too strong to actually, the glass won't expand in line with this CO2 trying to expand, that means the pressure builds up. It's just like if we blow into a balloon, because the sides of the balloon are elastic, the balloon expands. We're putting gas into the balloon, that this gas wants to fill up space, and the balloon accommodates it by expanding. The bottle, on the other hand, isn't elastic, so it won't expand, so the pressure builds up inside it. So that's the creation of pet nats. Pet nats compared to normal sparkling. With normal sparkling, we ferment our wine all the way through, and then we add sugar to it and rebottle it. It's a very controlled process because we know exactly how much sugar we're adding. So if we know how much sugar we're adding, we know how much carbon dioxide we're going to get. Pet nats are very similar, but instead of adding sugar, we're using the original grape sugar from the grapes themselves. And we bottle at a particular sugar level that we measure as accurately as possible. And then we put the cap on. And then this primary ferment, the very first ferment, finishes inside the bottle. And it's the CO2 from these original grape sugars that give us the pressure and provide us our carbonation. Good moment here, as a plant scientist from days gone, is spend a little moment to marvel actually where these sugars come from and what an underrated process this is. Really gets my goat actually that plants aren't considered a little more frankly as living organisms and how marvelous they are. They're often cast aside as our meat-free alternative, but we don't often think about what miraculous acts they play for us. Don't even get me started on the ethics of using plants. I've written a newsletter article on that. If you want to see it or read it, please let me know. I'll send it to you. Because plants are extremely complex organisms that have chemical responses to touch and from being cut and all manner of things. They can even communicate from one plant to another. But anyway, let's concentrate on where does this sugar come from? Well, sugar comes from the process of photosynthesis. And what an incredible process it is. They take a gas from the atmosphere, CO2, they use it with water, they combine it with water, and with the rays of the sun, photons, solar energy from the sun, through a beautiful series of reactions, they create a solid. So from a gas, they create a solid, all with the power of the sun. And they create glucose and fructose and some other sugars, as well as oxygen. And how good is oxygen? Incredible process. So I don't think we should ever forget just how miraculous photosynthesis is. But anyway, this is where our sugars come from, which are then fermented by the yeast. All right, so we talk about the role of yeast in fermentation, creating ethanol and carbon dioxide. And then we talked about how we use this to carbonate our beverages by enclosing this fermentation in the bottle such that the final fermentation takes place in there and all this CO2 is locked in. You can see this bottle on here. You might not be able to see it on the camera. I hope you can, but you can see those bubbles. That's simply the CO2 escaping from this pressure vessel to the atmosphere. The atmosphere, we're sitting here in Melbourne. The atmosphere here near the ocean is 1 atmosphere. It's one of the standard units of measure of pressure in the world, sort of in the living space. when we put the cap on and CO2 builds up in there, we're building up pressure in here above 1 atmosphere. So therefore, this pet nat here had more than 1 atmosphere of pressure inside it. So this CO2 is going from high pressure to low pressure. And these bubbles here are the CO2 escaping. Depending on how sparkling we want our wine, so how vigorously and how much CO2 is escaping from our wine when we open it, is dictated by how much CO2 we trap in here. So if we have what we call a lifted still wine, so a still wine with just a little bit of zzz on the palate, we generally add a bit less than 1 extra atmosphere of pressure to it as CO2. If we're making a frisson, like a Lambrusco, apologies to every Italian on earth for my pronunciation and accent I just used for Lambrusco, we add about 1 to 2 atmospheres of extra pressure. For a pet nat, a typical pet nat, we add 2 to 3. And for a sparkling like a champenois, we add between 3 and 6 atmospheres of extra pressure. Now, a good question is, why don't we add 3 to 6 atmospheres of extra pressure with a pet nat? Well, generally with a pet nat, we have other solids in the bottle, and you might not see it here, but there's some tartrate crystals, tartaric acid with potassium down the bottom, as well as some of the lees, so dead yeast, which we use to finish this ferment off. And if we have too much gas in there, they actually, what's called nucleate around the solids and actually use that to become quite explosive. So it's quite dangerous from a serving point of view to have a pet nat really beyond 3 atmospheres. And if you've got a lot of solids in your bottle, you really don't want it much beyond 2 atmospheres. So how does one work out the atmospheres of pressure we're going to get with the amount of grape sugar we have in the bottle? This is the age-old question. Well, fortunately for us, there's a fantastic gas law called the ideal gas law. And what this says is the pressure in a given volume of space is dictated by the amount of the gas within that vessel, as well as the temperature. And they're proportional. The way the gas law works is we have pressure and volume on one side, pressure measured in pascals, and volume measured in meters cubed. Not often a measure we use when we're talking about wine bottles, of course. And then on the other side of the equation, we have the number of moles, so the amount of the gas, number of molecules of the gas, sort of. We have a constant, which essentially just converts this equation to an energy form, and temperature, measured in Kelvin. Now, Kelvin is simply the degrees Celsius plus 273. Well, jump cut alert. Sorry, I didn't know how to edit the end of that video any better. So here we are in the spreadsheet. It fills me with fear about how poorly this will translate into the video. But anyway, we're here. So what this spreadsheet does is allows us to input any residual sugar level in our ferment to give us what the final pressure will be in our bottle. So down here, it gives us the final pressure in atmospheres in our bottle if the ferment goes all the way through, converting all this sugar to ethanol and CO2, and how that pressure will differ at different temperatures. So if we have 10 grams per litre residual sugar, we'll have 2.44 atmospheres of pressure above atmospheric in our bottle at 5 degrees, and at 30 degrees, 2.66 atmospheres of pressure. So again, if it's warmer, we're going to see the effect of that extra pressure in our bottle. We normally bottle our pet nats at about 13 or 14 degrees, 13 to 14 grams residual sugar, which leads here to between 3.2 and 3.45 atmospheres of pressure in our bottle. Now over here, my little ready reckoner, pet nat, remember, we want between 2 and 3 atmospheres of pressure, whereas this is over that. But, however, we mostly disgorge our pet nats, which is that process I spoke about before, where you turn the bottle upside down, open it up, and it blows out all the dead yeast and grape material from the neck of the bottle. Doing that, you lose some of your CO2, so lose some of your pressure. So if we overpressure them before disgorging, we find it gets down to about the right pressure post-disgorging. Now, if I was bottling without disgorging, I'd probably go around that 11 grams residual mark, which gets us between 2.68 and 2.9 atmospheres in our bottle. What this spreadsheet just does for us is just do some of the explanation about that ideal gas law behind the scenes. Here's the ideal gas law again for us, PV equals nRT. What this cell here just does is a rearrangement of that equation solving for the pressure. But it shows us what goes into it. So with 11 grams residual sugar, that is actually 0.06 moles of sugar or 0.122 moles of CO2, which is just less than 0.1 moles of CO2 per bottle. You can see also here I've put in the volume that CO2 wants to occupy at different temperatures as well. So you can see at 5 degrees, these is what 0.09 moles of CO2 actually wants to occupy around 210 litres of space. Whereas at 30 degrees, it wants to occupy 230 litres. So again, here's evidence of why that pet nat bubbled up so much more when it was warmer. And finally, Henry's constant tells us how much of this gas actually will dissolve in liquid at different temperatures. And this is almost the most startling. At 5 degrees, Henry's constant for CO2 in solution is 2.5. So 2.5 kilograms per meters cubed per atmosphere of pressure. Whereas at 25 degrees, it's half that. It's 1.2. So at 25 degrees, the solution will hold half as much CO2. So again, if it's warmer, we open up our pet nat, there's less of that gas in solution. More of it wants to come out of solution because it hasn't dissolved, so out it comes. So 2 lessons here. Colder on a pet nat is, the better. And 2, if we're going to disgorge or not, we have to work out if we're going to disgorge or not disgorge our pet nats before making them to determine what our final sugar will be. All right, so that is my discussion of some of the science behind pet nat. I did it off the cuff, so there's some weird dialogue in there, and obviously a terrible jump cut, but that's what you get with Konpira Maru Wine Chats. But thank you for coming on. Any hate mail, love mail, anything, just put in the comments. Any hate mail I'll respond to vigorously. Any love chat I'll respond to even more vigorously. So thank you very much.